Imagine, you are aboard a spaceship. There are no large windows. There is no epic music playing in the background. There is only the silence of the vacuum outside, and the soothing sound of your own instruments at work. You are millions of miles from Earth, and in front of you, he appears. From a distance, it seems almost beautiful, billowing bands of cream and orange curling up on themselves like paint poured into water. A huge red spiral so old that no living human being has ever known a world without it. The sunlight, far from here, still manages to draw a soft glow from its surface. You think, it's magnificent, and then the alarms start ringing. First one, then another, then all at the same time. His instruments begin to present impossible readings. The radiation outside has already exceeded any scale your spacecraft was designed to measure. The magnetic field around you is distorting every signal, every piece of data, every communication with the Earth. And at that moment, you understand. You are not approaching a planet. You're approaching something that's been around for 4.5 billion years, that destroyed worlds even before life existed on Earth, that shaped the fate of every planet in this solar system, including yours. You are approaching Jupiter, and Jupiter, it doesn't know you exist. This is the most violent place in our solar system that you can see with the naked eye in the night sky. A bright, constant point of light that children learn to identify at school, which amateur astronomers proudly point to through their telescopes, that appears on science posters, in textbooks, in tattoos of those who love the cosmos, and no one tells the truth about him. So today, we're going to talk. Let's start with the basics. Because most people hear Jupiter is big and nod their heads without really processing what it means. Big is not the right word. Incomprehensible is closer. You could cram more than 1,300 Earth-sized planets into Jupiter and still have room left. Its mass is 2.5 times greater than the sum of all the other planets in the solar system combined. Everyone, every planet, every moon, every asteroid, every comet that has ever orbited the Sun adds it all up, doubles it, and Jupiter weighs even more. But it doesn't stop there. Jupiter's diameter is approximately 143,000 kilometers. The Earth has just over 12,700. That means you could line up more than 11 Earth planets side by side to traverse Jupiter from one end to the other. 11. And yet that number doesn't capture reality, because numbers never capture Jupiter's reality. The human mind was built to understand savannas, rivers, mountains, not to understand that Jupiter orbits the Sun at an average distance of 778 million kilometers. When it is at its closest point to Earth, it is still more than 588 million kilometers away. Sunlight takes more than 43 minutes to reach it. A radio signal sent from Earth, traveling at the speed of light, takes the same amount of time to get there, and another 43 minutes for the answer to come back. Communicating with a probe on Jupiter means waiting almost an hour and a half for each message exchange. In this remote place, in this abyss of distance, there is this colossal thing spinning on itself at an absurd speed, completing a full rotation in just 10 hours. The most massive planet in the solar system is also the fastest spinning, and that rapid rotation is part of what fuels everything that makes it mortal. But what really disturbs is not the size, it's not the distance, it's not the speed. That's what that size almost became. Jupiter is a failed star. If during its formation it had accumulated only 80 times more mass than it accumulated, nuclear fusion would have ignited in its core. We would not have a fifth planet. We would have a second sun, a binary star system, two suns in the Earth's sky, days with no real night, radically different seasons, a possibly unrecognizable or non-existent Earth. Life as we know it may never have existed. Instead, we are left with something perhaps more dangerous than a star. We are left with a gas giant with no solid surface, with pressures that turn physics into science fiction, with a magnetic field that kills everything that gets too close, and with a thirst for destruction that did not begin yesterday, that never ended. Look at Jupiter's atmosphere. What you see is not climate. It is chaos on a scale that defies any human comparison. Those chromanderin streaks that look so serene from afar are actually jet streams crisscrossing the planet at more than 600 kilometers per hour. They are not breezes. These are not strong winds. They are walls of gas moving faster than sound moves on Earth, and they never stop. There is no season of the year on Jupiter that calms these currents. There is no winter that freezes this furor. There is no spring that brings calm. They have been around for billions of years and will exist for billions more. These jet streams are not uniform. They run in opposite directions, some eastward, others westward, creating sheer boundaries between them where the gas is twisted, torn apart, and transformed into chaotic turbulence. It is on these borders that storms are born, where pressure systems form, grow, devour energy, and become meteorological monsters that last for decades. And in the midst of all this, there is it, the Great Red Spot, a storm, a single storm that has been raging for at least 400 years, possibly much more. The first astronomical records of it date back to the 17th century, but it may be much older. No human being who has ever lived on Earth was born into a world where such a storm did not exist. It was there when Newton discovered gravity. It was there when humanity first sailed the oceans. It was there when we built the first cities, when we wrote the first books, when we lit the first fires. She witnessed it all, and it keeps spinning. And it's big enough to swallow the Earth whole and still have space left. Winds at the edges of this storm exceed 400 kilometers per hour, and this is considered calm by Jupiter's standards. The storm rotates counterclockwise, fueled by temperature differentials between the upper and lower layers of the atmosphere. Its reddish coloration comes from complex chemical compounds, possibly composed of sulfur and phosphorus, that are carried from deep to the surface by the storm's circulation. In the last 150 years, since we began observing it with modern telescopes, the Great Red Spot has shrunk. It has already been 3 times higher. Today, it is slightly larger than the Earth. Scientists debate whether it is dying or just morphing, whether it will one day disappear altogether or reinvent itself into another form of violence. But while we debate, it keeps spinning, relentless, indifferent, eternal for all the practical effects that the human scale can measure. But the storms aren't the scariest part. The deeper you go, the worse it gets. Jupiter has no surface, there is no ground, there is nowhere to land, nowhere to stop, nowhere to survive. The atmosphere just gets denser and denser as you go down. The pressure increases with each kilometer, with each meter, with each centimeter. The temperature rises, the density increases. What was gas is becoming something between gas and liquid, a mixture that has no precise name in human experience, because there is nothing like it on Earth. And at some point down there, something happens that shouldn't be possible. Hydrogen, the simplest gas in the universe, the first element in the periodic table, the most abundant in the cosmos, turns into liquid metal, liquid metallic hydrogen, a state of matter that does not exist anywhere on the surface of the Earth, which only exists under pressures so absurd that they reach 3 million times the Earth's atmospheric pressure. Under these conditions, the very structure of atoms bends. The electrons are stripped from the hydrogen nuclei and begin to flow freely as in a conductive metal. Hydrogen, which is normally an insulator, becomes an electrical conductor. And these streams of electrons, flowing through liquid metallic hydrogen, driven by the planet's rapid rotation, generate the most powerful magnetic field in the solar system. The magnetic field. The Earth also has a magnetic field. It protects us from solar radiation, deflects charged particles. It makes life possible. Without it, the solar wind would have eroded our atmosphere billions of years ago, and the Earth would today be a barren, cold, dead desert. Jupiter's magnetic field operates in a completely different dimension. It is approximately 20,000 times stronger than Earth's. If you could see it with the naked eye, if somehow your eyes were able to detect magnetic fields, it would appear larger than the full moon seen from the ground, 20 times larger than the full moon, a colossal structure dominating the night sky, invisible, silent, terrifying. It stretches millions of kilometers into space, reaching the orbit of Saturn. It is the largest structure in the entire solar system, larger than the Sun itself in volume, although the Sun is much more massive. It is a gigantic magnetic bubble, called the magnetosphere, that surrounds Jupiter and all its moons, and it's completely invisible. But here's what no one tells you about this magnetic field. It does not protect, it destroys. Jupiter captures charged particles from the solar wind, protons, electrons, ions, and accelerates them within its magnetosphere to speeds close to the speed of light. These particles form radiation belts around the planet, invisible layers of death that envelop Jupiter like poisonous armor. The intensity of this radiation is equivalent to billions of simultaneous X-rays. It would kill an unprotected human being in minutes, not in hours, not in days, minutes. And it would not be a soft death. Ionizing radiation at such extreme levels destroys the body's cells at the molecular level. It breaks DNA, destroys fabrics, the organs stop, the nervous system collapses. Minutes. When NASA sent the Juno spacecraft to orbit Jupiter, engineers had to build a titanium vault, especially to protect the spacecraft's electronics, as safe as if they were keeping something precious from a thief. That safe weighs 200 kilograms, and even with that protection, Juno can only make close passes of Jupiter for a few hours at a time before radiation threatens to destroy its systems. Think about it. A machine built by the most advanced engineers in human history, armored with titanium, designed specifically to survive Jupiter. And even then she manages to stay close to him for only a few hours before she needs to retreat. Like a diver who can descend only so far before pressure threatens to crush him. Like a climber who can only stay on the summit for minutes before the cold threatens to kill him. Except that here, the boundary is not physical for the human body, it's electronic for machines that we build with all our technology. Jupiter is more dangerous to our best machines than the bottom of the ocean or the top of Everest, or to our bodies. And the Galileo probe that plunged directly into Jupiter's atmosphere in 2003 received a radiation dose equivalent to 25 million dental X-rays before being crushed, melted, and vaporized by the planet's pressures. 25 million X-rays before being completely destroyed. Jupiter is dangerous in a way. It's dangerous otherwise. It is dangerous in every way simultaneously. The pressure crushes, radiation kills, gravity imprisons, storms destroy. The magnetic field accelerates particles to relativistic speeds. There is no safe approach to Jupiter. There is no truly safe orbit around it. Every mission we've ever sent there has operated on borrowed time, counting down the hours, managing every mile of distance as if it's the difference between survival and silence. But what Jupiter does to the space around it is just as brutal as what it does to what goes into it. Jupiter is a cosmic wrecking ball. Its gravity is so immense that it has fundamentally altered the formation of the entire solar system. Scientists believe that in the first billion years of the solar system's history, Jupiter migrated inward, approaching the Sun, sweeping away everything in its path, dispersing debris, destroying potential planets, preventing Mars from growing to its maximum potential. Mars should be bigger. With the position it occupies, with the materials available during the formation of the solar system, models indicate that Mars should have grown to the size of Earth or larger. Instead, it's a small, dry, cold planet with a rickety atmosphere that barely retains enough heat to keep liquid water on the surface. Jupiter prevented this. Jupiter's gravity perturbed the material that should have been accumulated by Mars during its formation by scattering it, accelerating it, pushing it into orbits that would never pass close to Mars again. Jupiter literally prevented Mars from becoming what it could have been. There is a theory called the Great Taxi. It suggests that Jupiter came as close as the current orbit of Mars before being pulled back outward by Saturn's gravity. During this migration, it would have destroyed or ejected most of the material from the inner solar system. The asteroid belt between Mars and Jupiter. They are not the remains of a destroyed planet. They are the remains of planets that never had a chance to form. Billions of pieces of rock and metal that, in any other solar system without a Jupiter in the way, could have accumulated into a solid planet. But Jupiter was there, and Jupiter did not allow it. And this influence is not only historical, it is continuous. It happens now, today. Comets, asteroids, wandering objects drifting through the solar system. Jupiter acts as a gravitational vacuum. He absorbs them, deflects them to the Sun, or throws them out of the solar system altogether. In 1994, we saw this happen in real time. Comet Shoemaker-Levy 9 was captured by Jupiter's gravity and torn apart into 21 fragments. Jupiter's gravitational tide literally tore the comet to shreds as it approached. Then, one by one, these fragments collided with the planet's atmosphere at 60 kilometers per second. The impacts left scars larger than the Earth. The energy released was equivalent to millions of nuclear bombs. Astronomers around the world pointed their telescopes at Jupiter and watched. For the first time in recorded history, humanity has observed a planetary collision in real time, not in fossils, not in ancient craters. Live. If that comet had hit the Earth, the word is extinction. Some scientists argue that Jupiter protects us, that its gravity acts as a shield, deflecting dangerous comets before they reach the inner solar system. that without Jupiter, Earth would have been bombarded much more often by objects the size of those that caused mass extinctions, that we owe, in part, our existence to the fact that Jupiter is out there, absorbing what could destroy us. Others point out that this same gravity also sends objects toward Earth, capturing comets from distant, safe orbits and redirecting them to trajectories that crisscross the inner solar system, increasing the risk of impacts that would otherwise never happen. The truth is probably somewhere in between. Jupiter gives, Jupiter takes it away. It has always been like this. It always will be. He has no preferences. He has no intentions. It is not deliberately protecting us. It is not deliberately attacking us. He just exists, and his existence transforms everything around. Like an ancient god who knows no prayers and does not respond to supplications. It just is. It just acts. According to physical laws that were not written for our convenience, you might think that at least Jupiter's moons are safe. After all, they are worlds in their own right. Some of them are larger than planets. Some have atmospheres. Some have oceans. They are places where we hope to find life. But even Jupiter's moons exist in hell. Jupiter has 95 confirmed moons, 95 worlds trapped in orbit around a gravitational tyrant. Most of them are captures of objects that passed through the solar system, were attracted by Jupiter's gravity, and never managed to escape. Permanent prisoners, condemned to orbit forever, and none of them entirely escapes the violence of the planet that imprisons them. Io is the most visible proof of this. Io is the closest moon to Jupiter and is the most volcanically active celestial body we know of in the entire observed universe. Not because of internal heat, as it happens on Earth, where core heat and radioactivity fuel volcanism, but because Jupiter's gravity literally kneads Io like bread dough. The tidal forces, the same phenomenon that causes the moon to cause the tides in Earth's oceans, but thousands of times more intense, are constantly twisting and compressing the interior of Io. This friction generates heat, very hot, enough heat to keep Io's interior partially molten, with magma flowing just below a thin, unstable crust. Eruptions from Io are not like terrestrial eruptions. It's not mountains slowly emitting smoke and lava. These are violent explosions that launch volcanic material hundreds of kilometers high. The largest plume ever observed on Io extended more than 500 kilometers above the surface. Lava oozing at temperatures that surpass the hottest terrestrial eruptions. Entire surfaces redesigned in a matter of months. Io's surface completely reshapes every few years. There are no ancient craters on Io. Everything is covered, erased, rewritten by the continuous violence that Jupiter imposes on her. Io is not a moon. It is a perpetual victim. So there is Europe. Europe is different. Europe is the place that intrigues us the most, fascinates us the most, keeps us up the most, at night thinking about what might be there. Europa is covered by a thick shell of ice, a smooth white surface, crossed by reddish lines like cracks in an eggshell. These cracks are fractures in the ice crust opened and closed by the same tidal forces that torture Io, but more gently here. The ice moves, it reopens, like a wound that never heals completely. And under this ice, there is an ocean, a global ocean of liquid water, salty, with depths estimated to be between 60 and 150 kilometers. In comparison, the deepest point in the Earth's ocean, the Mariana Trench, is just under 11 kilometers. Europa's ocean can contain 2 to 3 times more water than all of Earth's oceans combined, warmed by Jupiter's tidal forces, with organic ingredients detected by our instruments, with enough heat to keep the water flowing in the depths, even hundreds of millions of miles from the sun, with salt, with minerals, with energy, with the ingredients of life. The question that no scientist can answer is still simple and terrifying at the same time. What's swimming in this ocean? It could be nothing. It's probably nothing. The probability is still greater than we imagine for the void, but it could be something. A bacterium, a microorganism, perhaps something more complex, adapted to millennia of darkness and pressure and alien chemistry. And if it's something, even if it's just a microscopic cell, surviving in an ocean that has never seen sunlight, it changes everything. This means that life is not an accident of the Earth. It means that life is what the universe does when conditions allow. It means that in every solar system with a Europa-like moon, there could be life. And there are billions of solar systems, billions of possible moons. Europa's ocean may be proof that we are not alone. But reaching this ocean is almost impossible. Europa's surface lies within Jupiter's radiation belts. Any spacecraft that lands there will have to endure a constant bombardment of high-energy particles that destroy electronic components in a matter of hours. After landing, it would need to drill through miles of ice using technology that doesn't yet exist in mature form to have any chance of reaching the water below. And even then, operating in an environment that was not designed for the survival of human machines. Europe holds secrets that may be the most important in the history of science, and Jupiter does everything so that we do not reach them. Ganymede is the largest moon in the solar system. Larger than the planet Mercury. If it were in orbit around the Sun instead of Jupiter, it would be classified as a planet. With a diameter of 5,268 kilometers, it is a genuine world, with its own geology, its own past of internal activity, its own differentiated layers of rock and ice. And it has something unique, the only magnetic field of any moon we know of. A magnetic bubble of its own, created by a core of liquid iron in its interior, generates a tiny magnetosphere within Jupiter's colossal magnetosphere, a protection inside a prison. But even that is not enough. Radiation from Jupiter penetrates. It always penetrates. Ganymede's magnetosphere is too small to completely block what Jupiter dumps on it. Ganymede survives, but survives wounded, bombed, aging under the invisible violence of her oppressor. And Callisto, the farthest moon of the Big Four, the one orbiting farthest from Jupiter, is perhaps the most bombarded world in the solar system. Its surface is a geological archive of 4 billion years of impacts. Each crater is a scar from a comet or asteroid that Jupiter has captured and redirected. Callisto is the shield, the target that absorbs what Jupiter does not devour alone. A moon transformed into an archive of its master's gravitational crimes. These moons are not refuges, they are prisoners, trapped in orbit around a monster that heats them, tears them apart, bombs them, and uses them without ever realizing they exist. But we get it, and we decided to go there. The history of missions to Jupiter is not a history of conquest. It is a story of sacrifice, of machines sent to meet destruction in the name of knowledge, from engineers who knew they were building ships to die and built them anyway. The first mission to survive the Jupiter flyby was Pioneer 10 in December 1973. No one knew for sure if she would survive. Jupiter's radiation belts were theorized but not measured. Models existed, but models are just predictions, and Jupiter has a particular way of making predictions irrelevant. Pioneer 10 entered Jupiter's environment like an explorer entering an unknown cave without knowing what was inside, not knowing if it would get out. She survived, damaged, but survived, and what it brought back shocked scientists. The radiation was more intense than any model had predicted. The magnetic belts were more powerful, more extensive, more deadly than we imagined. Some of Pioneer 10's instruments were damaged by radiation before it even made its closest pass by the planet. Pioneer 11 came soon after, in December 1974, passing even closer by using Jupiter's gravity to catapult itself toward Saturn. Pioneer 11 was the first spacecraft to use the planet as a gravitational sling, stealing speed from Jupiter to continue its journey. One of the most elegant maneuvers in the history of space exploration. And what we learned from these two pioneers has completely redefined our understanding of the solar system. Then came the Voyagers. Voyager 1 arrived in March 1979. Voyager 2 in July of the same year. Sister ships, built together, launched within months of each other, destined for a journey that would take them beyond the limits of the solar system. But first, Jupiter. What the Voyagers showed us was beyond expectation. For the first time, we saw the great red spot in real detail, not as a blurry dot in a telescope, but as a living storm spiral, spinning with a violence that images could barely contain. For the first time, we saw Jupiter's rings. Yes, Jupiter also has rings, invisible from Earth, too faint to be detected before, revealed only when Voyager passed the backside of the planet and saw them lit up against the blackness of space, like dust in a beam of light. And for the first time, we saw the volcanoes of Io. No one expected this. No model, no theory, no prediction had suggested that Io would be volcanically active. The expectation was a dead, frozen moon with no recent geological history. And here was a moon exploding into space in real time, with plumes of material shooting hundreds of miles above the surface, with lava lakes visible on the surface. with a world constantly erupting. It was one of the most astonishing discoveries in the history of space exploration. A NASA scientist, upon seeing the first images, said that it was as if someone had lit Io while they were not looking. The Voyagers flew past Jupiter and kept going. They went towards Saturn, Uranus, Neptune, and then they continued even more. Voyager 1 today is the farthest man-made object from Earth, more than 23 billion kilometers from the Sun. In interstellar space, beyond the influence of the solar wind, in a darkness that no human eye will ever see directly, it still transmits signals that take more than 22 hours to reach us. She began the journey by passing by Jupiter. After the Voyagers, NASA wanted more. He wanted a mission that would not only pass by Jupiter, but that would stay, that orbited, to study the planet for years instead of hours. The result was the Galileo probe. Galileo was launched in 1989 and arrived at Jupiter in December 1995. The journey lasted 6 years, not because Jupiter was unreachable at that time, but because the spacecraft used flybys of Venus and Earth to gain gravitational speed, describing a complex and elegant trajectory through the inner solar system before finally departing toward the giant. To enter orbit around the planet, it had to slow down, which meant diving into Jupiter's environment, being exposed to radiation long enough to make the maneuver. The engineers calculated every second of exposure, every mile away, managing the health of the ship as doctors manage a patient in surgery, aware that any mistake would be fatal and irreversible. Before entering orbit, Galileo launched a separate probe directly into Jupiter's atmosphere, a descent pod. The probe entered the atmosphere at 170,000 kilometers per hour, the highest speed any man-made object had reached when entering a planet's atmosphere. The heat shield reached temperatures of 15,000 degrees Celsius, larger than the surface of the Sun. The probe survived the entry. He opened a parachute. It started to go down. For 57 minutes, it transmitted data as it descended through Jupiter's atmosphere, measuring pressure, temperature, chemical composition, wind speed. For 57 minutes, a human-built machine survived inside the monster. It recorded winds of up to 700 kilometers per hour in the upper layers of the atmosphere. It measured temperature and pressure, increasing non-stop as it descended. It sent back data on the planet's chemical composition, revealing much smaller amounts of water than scientists expected. Then, silence, pressure, and heat from Jupiter's depths crushed and vaporized the probe. She became part of the planet, dissolved, absorbed, as if it had never existed. The Galileo probe itself was in orbit for 8 years, from 1995 to 2003. 8 years studying Jupiter and its moons, making 35 close passes, confirming the existence of the ocean beneath Europa's ice, revealing Io's volcanic violence in unprecedented detail, mapping Ganymede's magnetic field, discovering evidence of oceans also on Callisto, and possibly Ganymede. When the fuel ran out, NASA made a deliberate decision. They couldn't just abandon the spacecraft in orbit. In time, an uncontrolled spacecraft could collide with Europa or Ganymede, potentially contaminating the very oceans we expected to find life with terrestrial bacteria. It would be a scientific and ethical catastrophe, an irreversible contamination of a world that can harbor life. Then they gave Galileo a final order: dive in. On September 21, 2003, the Galileo spacecraft plunged directly into Jupiter's atmosphere. He received a radiation dose equivalent to 25 million dental X-rays. It faced winds of hundreds of kilometers per hour. It fought to keep its antenna pointed at the Earth for as long as possible, transmitting data until the last second that physics allowed, and then Jupiter devoured her. Heat, pressure, destruction. The probe that had spent 8 years studying the monster was consumed by it. In the end, melted, vaporized, incorporated forever into the planet she studied. Galileo became Jupiter. After Galileo, there was silence. Jupiter was without visitors for years. The technical, financial, and scientific challenges of each new mission grew. The radiation belts, the magnetic field, the impossible pressures each mission required increasingly sophisticated engineering solutions. But there were questions that could not remain unanswered. What's in Jupiter's core? How exactly did the magnetic field form? What fuels storms in their deepest layers? Why has the Great Red Spot been around for centuries? What's under Europa's ice? In August 2011, NASA launched the Juno spacecraft. But Juno is not like previous probes. Juno was built to do something that no spacecraft had done before: enter a polar orbit around Jupiter, passing directly above the planet's poles where the magnetic field is most concentrated, plunging into the magnetosphere, and then exiting rapidly before radiation could destroy it. Each close passage of Juno, called perijove, lasts only a few hours. The ship enters, collects data at full speed, and leaves. Come in, collection, get out. Like a thief, stealing secrets from a safe before the alarm goes off. Like a diver who goes to the bottom and rises before the oxygen runs out. Calculating every second, managing every mile. To protect its electronic components, engineers built the titanium safe. 200 kilograms of heavy metal enveloping the spacecraft's most sensitive equipment. A space vault flying around the most violent planet in the solar system. And what Juno found changed our understanding of Jupiter in fundamental ways. Jupiter's core is not solid as we thought. It is a nebulous region of dense material that extends over a surprisingly large fraction of the planet. Scientists believe that billions of years ago, an object the size of several planets collided with Jupiter while it was still forming, an impact so colossal that it mixed the core, scattering it, turning what should have been a dense sphere at the center into a confusing gradient that permeates much more of the planet than we should expect. Jupiter carries within it the scar of a planetary collision. Jupiter's storms are not superficial phenomena. They extend hundreds of miles into the planet, deep roots of meteorological violence, penetrating layers that we never see from the outside. The Great Red Spot has roots, go deep, and Jupiter's poles that were never well observed before. Juno turned out to be covered by gigantic cyclones arranged in astonishing geometric patterns. At the South Pole, 8 huge cyclones arranged in an octagon around a central cyclone. At the North Pole, 8 cyclones as well, standards that defy any atmospheric model we had. Jupiter still surprises us. Juno is still there. Its mission was extended several times as the probe continued to perform beyond all expectations. It still orbits, still dives back and forth, stealing secrets from a giant who doesn't realize he's being studied. And the future. In October 2024, NASA launched the Europa Clipper mission, the largest interplanetary spacecraft ever built by the United States, with more than 30 meters of wingspan of solar panels, built specifically to answer a question that humanity could never accurately formulate before the space age: is there life beyond Earth? Europa Clipper will arrive in the Jupiter system in 2030. It will make more than 50 close passes of Europa, rapidly diving into Jupiter's radiation environment, collecting data and retreating before the systems are damaged. It will analyze the chemical composition of the vapor plumes that gush through the cracks in Europa's ice crust. It will map the thickness of the ice with unprecedented precision. It will measure the magnetic field induced by the ocean below. It will look for signs of heat, of organic chemistry, of anything that suggests that those dark, deep waters are alive. It may be the most important mission in human history, or it can confirm that Europa's ocean is just water. Cold, dark, barren, beautiful in its vastness, but empty. But even if it's barren, the ocean exists, and where there is ocean, there is possibility. And where there is possibility, there will always be humans wanting to go deeper, to know more, to understand more. That's what we are. It's what we've always been. The European Space Agency is also preparing its mission to JUICE, Jupiter Icy Moons Explorer, launched in 2023. It will arrive in the Jupiter system in 2031 and spend its final years in orbit around Ganymede, the first spacecraft to orbit a moon of a planet other than Earth. 2 visitors arriving at the same time, 2 sets of human eyes facing Jupiter's moons simultaneously. A convergence of curiosity and engineering and courage in the orbit of the most intimidating planet in the solar system. Jupiter tries to stop us. We kept trying anyway. But Jupiter does not wait for us. Jupiter never waited for anyone. It's been here for 4.5 billion years. It was here before the Earth existed as a solid planet, before Earth's oceans formed from comets and primordial steam, before the first living cell divides in a pool of warm water somewhere on the young planet, before trilobites, before the dinosaurs, before the first mammals, before the first humans looked up at the sky and wondered what those lights were. And during all this time, he never stopped being violent. It has never ceased to be mortal. He never stopped being hungry. The Great Red Spot is shrinking. Scientists have been monitoring this for decades with growing fascination and a twinge of something that may be melancholy. The storm that was 3 times larger than Earth is now barely larger than Earth. It's shifting, compressing vertically as it narrows horizontally, getting taller and more intense as it shrinks, like a flame that gets hotter when it's about to go out, or like a monster that concentrates before attacking. No one knows for sure. As the great spot shrinks, other storms arise around it. Some merge with each other in a chaotic dance of absorption and destruction. Others are swallowed by the spill. Still others grow into temporary rivals, large enough to be seen from Earth for a few decades before disbanding. Jupiter's magnetic field pulsates. It varies with the rotation of the planet. It interacts with the solar wind in ways we don't yet fully understand. Jupiter's auroras explode and go out at the poles, lights that eclipse any Earth's auroras, powered by Ios, volcanoes, throwing material into space that is then captured and channeled by the magnetic field to the planet's poles. Ios volcanoes continue to erupt. Right now, as you listen to this, Io is exploding somewhere hundreds of millions of miles from here. Lava is dripping, plumes rising into space. The perpetual violence of a moon that has never had peace, that will never have peace, that will exist in geological agony as long as Jupiter exists. And Europe guards its ocean in silence, in absolute darkness, under miles of ice, perhaps with something swimming in these depths that has never seen light, that will never know that there is a universe above its ice ceiling, that will never imagine that on some distant planet, creatures made of stardust are building machines to meet it. Or maybe there is nothing, just water, just silence, just the loneliest ocean in the entire solar system. When you look up at the night sky tonight, and if the sky is clear and you know where to look, you'll see a bright point of light that doesn't blink like the stars, that shines with an almost annoying constancy, that looks smaller than it deserves to be given everything we know about it now. Know what you're actually seeing. You're not seeing a peaceful neighbor. You're not seeing the textbook's favorite planet. You're seeing a storm that's been going on since before the dinosaurs, a source of radiation that would kill you in minutes. A gravitational well that has shaped the fate of all the worlds in this solar system, including the world you call home. A planet killer that prevented Mars from being what it could have been. A comet eater that may have saved us from extinctions that never happened. A moon jailer who holds in his system an ocean that can harbor life. You're seeing a star that's almost gone. A star who failed to become what she was meant to be, and it became something stranger, more violent, more fascinating. You are seeing something that existed billions of years before you, and that will exist billions of years after you. That destroyed worlds, that imprisoned moons, that devoured probes, who molded this solar system to his will without having any will, who never knew you existed. Jupiter is not the king of the planets because it is noble. He is not the king because he was chosen. He is not the king because he was crowned. He is not the king because he deserves the throne. He is the king because nothing else has survived long enough to challenge him. And when you realize that, when you really process what that point of light in the sky really is, you're going to understand something about the universe that no self-help book is going to tell you. The universe was not built for our survival. The Earth is the happy accident. Jupiter is the rule. We are the impossible exception. A cosmic coincidence so improbable that its existence should be a source of constant astonishment. We exist in a tiny temperature band around a medium-sized star, protected by a weak but sufficient magnetic field, in an orbit stabilized in part by the gravity of a monster hundreds of millions of kilometers away, and we have the audacity to send machines to study this monster, the courage to point telescopes and cameras and instruments at the most violent thing we can see with the naked eye, the impossible curiosity of wanting to know what is inside him, around him, inside his moons, under his ice. That's what we are. We are the species that looked at Jupiter and said, I want to get closer. The solar system is much more violent than it appears when you look up at the night sky. The stars seem quiet. The planets seem like serene points of light. Everything seems to be at peace, but it is not. It never was. Jupiter is the brightest proof of this literally. It's the brightest proof, because it's the brightest object in the night sky after the moon and Venus. This beauty you see is real. The glow is real. The majesty is real. And it's also a trap. The most perfect beauty in the universe is often the most lethal. Saturn's rings are the bowels of a dead moon. The colorful nebulae that decorate astronomy posters are clouds of gas and dust that are lethal at impossible temperatures. The black holes we photographed in those golden circular images that went viral are points in space where physics breaks down and nothing escapes. And Jupiter is the most beautiful killer of all. A golden giant with a banded halo and a red storm like an eye open for centuries, looking out at the solar system like a Claude who knows everything belongs to him. Because it belongs. If this video has changed the way you'll look at the sky going forward, if the next time you see that point of steady, bright light, you feel a shiver you didn't feel before. So we did what we came to do. The universe is immense. It's violent. It is indifferent to our existence. And it is absolutely extraordinary. There is much more to explore. Saturn with its rings that are graveyards of moons. Mars with its scars from a past that should not have ended as it did. The black holes that inhabit the center of galaxies like silent gods. Exoplanets orbiting distant stars in conditions that defy everything we call possible. If you want to continue on this journey, if you want to continue looking at the universe with new eyes, with that mixture of fear and amazement that only the cosmos can provoke, then subscribe to this channel. Each video is a doorway to a place where science and poetry meet, where the facts are so extraordinary that they need no exaggeration, where the universe speaks for itself and we just need to listen carefully. Activate the bell so as not to miss the next one. And in the comments, tell us what impressed you most about Jupiter Europa's ocean, the violence of the radiation belts, the prisoner moons, the fact that Jupiter was almost a sun. We're curious to know what was left in your head after all this, because the most interesting conversation about the universe doesn't happen in space. It happens down here, among us. See you in the next video.